Good day, everyone. I am Stephanie Grace Pisiton, and our lessons for today is solving linear inequalities. What is linear inequalities? A linear inequality is an inequality that contains an algebraic expression of degree 1. Let's just focus on the word linear. What I mean by that is that what we're talking about today will be degree 1 functions. And that sort of makes your life a little easier. We're not gonna have x squared, x cubed, all that to deal with just x. And by inequality, well, okay, just in a second, you'll see what I mean by that. Here are some examples of linear inequalities. You can see when we see x values. There it's just x as we have to deal with. They might be on both sides. There might be also in a bracket. At first glance, nothing different. There aren't actually two differences we need to talk about. One I'll get to on the next slide. Is that in an equation you get one answer. Your final answer is just a number, x equals 3. Whereas in an inequality, your answer is x less than 3. It gives you a whole domain. It gives you a whole list of numbers. All the numbers less than 3. Solve this inequality and you will think, well, that's really big deal. Yeah, I understand that. I could see that on the last line, x less than 3. And so that's not a huge difference. It's just a difference on what your answers mean. And maybe you're not shocked by that at all. The difference is just gonna take a couple slides to get to that. Don't worry about that. I'll bring it up in just a minute, but for now, what's really the difference between the two answers is that when we get x equals 3, in the equation we have one answer that's less than 3 and an inequality. There's a lot of numbers to satisfy this inequality and we can always represent the solution to our inequality in several ways before, like set notation x such that x is a real number. Example, x is less than 3. We can do interval notation. The brackets are indicating we're gonna indicate a low x value and a high x value. In our example previously, the low value is negative infinity with a circular bracket around the 3 as well because it wasn't less than or equal to. So you can see how the answer might change if it was less than or equal to. We use a square bracket on that side and you can also represent your answer the number line like we did the previous chapter. We're talking on all the numbers less than 3. And maybe the number line makes that clear that we're not just taking about the number 3, we're talking about all the numbers that are less than 3. And that's one of the difference with inequalities. Let's talk about how numbers are used on the number line. For instance, when we look at the numbers on a number line, I'm just gonna do a few numbers on her. I'm going to do like 0, 1, 2, and 3. And this is my first attempt at explaining the issue here. I want you to take a look at the numbers 3 and 2. Notice that 3 is greater than 2. You're not surprised by that because the number 3 is farther from 0 than 2. I'm really trying to give you some extra weapons there by describing 3 differently than maybe you've heard it. Described before, 3 is 3 away from 0, 2 is 2 away from 0, so 3 is greater than 2. But look on this side, negative 2 is greater than negative 3. That's a different result than we got on the positive side. When you switch over the negatives, we count backwards. We go more and more negative. As we go to the left, so the numbers get bigger like the digits get bigger. But the number value is actually getting less all the time. That's not the way we do the positive side. Bigger digits means bigger numbers on the positive side. On the left side, 0 is the bigger digits, it means less values. So when you flip from one side negative, you've got to reverse the order, okay? always put that onto your brain. You've got to reverse the order. I see what the problem is. Well, let me do a very simple one. Let's say 3 is less than 5. No tricks, 3 is less than 5. There's no question about that. If I multiply or divide by a negative, watch what happens. So I'm going to multiply both sides by -1. I get -3 and -5. And I'm not going to put an inequality in between. I'm just gonna think about what's happened here. I've multiplied both sides by -1 and now think about in it your brain. Which one's bigger, -3 or -5? -3 is the bigger, and so by switching the sign on both sides of the inequality, I've switched the direction of numbers, and so I have to flip these things on. For this example, because this is the big deal of this lesson, a seemingly harmless example, doesn't seem like a big deal, doesn't seem different than the previous example. It says -3x minus 27 less than or equal to 0. Steps would seemingly be the same. You add 27 to both sides, and so I get -3x is less than or equal to 27. And then there's a big moment here. This is the right way to do this, and it's hard to understand why, and I've got to spend some time explaining why we do what we do. Then I divide both sides by -3. And do you see what happened? Why do we reverse the inequality sign when we divide or multiply both sides by a negative number? Why do we do that? Let's ignore that for a second. I'm just gonna finish it off, just take it for granted. I'm gonna explain something that goes on. I get why we have to reverse that now, and we'll just carry on with finishing the solution, which is I get x greater than or equal to -9. No big deal, but why do we reverse that sign? Well, there's the answer on the number line. X greater than or equal to -9. Notice the square bracket right there? Sorry, the filled in that right there. When we're doing x greater than or equal to -9. Okay, so now why was that been reversed? Here, I get x greater than or equal to -9. And here a square bracket on the -9 because we're including that answer. Okay, this note except try to understand why that happened when you divide or multiply by a negative. You've got to switch this inequality over. Okay, now we have left some practice problems. Some of them might have that little negative tricks, some of them don't have the negative trick. You've got nothing to worry. The way that appears on her is to solve this question, and there's a couple of ways you could do. First, then I go okay. I get 28x minus 42 is less than or equal to 48. And then, I'll add 42 to both sides. And I get 28x is less than or equal to 42 plus 42. And I get 28x is less than or equal to 84. Then, to get x by itself, I divide both sides by positive 28. And since I'm dividing by positive, I'm not worried about switching this inequality, so it stays as less than or equal to, and I get 84 over 28. Well, I can do better than that. I'm gonna divide top and bottom by 7, and I think I get 12 over 4. Oh, I can do better than that. X is less than or equal to 3. Isn't that nice? It divided out beautifully, like that, so x is less than or equal to 3. Next example, solve the following inequality again. I'm just gonna do a distribution here, and they get a -5x plus 15 greater than or equal to 2x plus 10. I'm gonna bring 2x over. Let's make it a -5x minus 2x, and I get a greater than or equal to 10 minus 15. I brought the 15 over in the same step. Simplifying over her, I get -7x greater than or equal to -5. But now, This final step right here, I've got to get x, but to get x by itself, like I divide by -7, and so I get x something 5 over 7. I just cancel those negatives. When you are switching, then you're dividing by negative numbers. Multiplying negative numbers, you've got to switch this inequality because the direction of everything switch, you'll get wrong answer if you don't watch out for that. That's the big deal of this lesson. I have two less than signs. It's actually no big deal. The only difference is you're going to be trying to isolate x in the middle. So when you're trying to isolate x in the middle, I'm just gonna add 8 to all three sections of the inequality. So when you've got a three-part inequality, you've got to add or subtract or multiply or divide each section by the same number. So here I get 30 less than 2x less than 62. Focusing on the middle part of the inequality. And the middle part, I want to isolate x. And here I got a 2x in there. So I got divide everything, right? And so I get 15 less than x is less than 31. And once I get to that final answer, that should a little familiar, and that we've had domain statements. Before that, had two double inequalities like this. It's actually called a double inequality. I know I referred to it as a triple one. There's you sort of follow that I was saying, but it's called a double inequality. I'm showing her last one. Here we go, a double inequality. Her, but what happened is I've got the same x value in both the left and the right hand part of it. So this one can be isolated. I like doing these ones like this because it really helped me to see what I'm up to. I'm trying to get rid of -5 in the middle. I'm focusing on the middle. I want to isolate x in the middle, so I'm going to add 5 to all the three sections, and I get x minus 24 is less than 4x is less than x plus 17. And now I want to get rid of those x on the outside, so I'm going to subtract x from each section, and so I get -24 less than 3x is less than 17. So do you see what that having the same x value on the left and right part of this inequality made it so I could isolate x in the middle if those x aren't the same in those other two sections, like the one I did here. Then it's not easy to solve, but again, questions don't ask you to solve those, they ask you to check a specific x value back to her, where I was trying to isolate x in the central. So the last thing I got to do is divide by in all sections, and I get -8 less than x less than 17 over 3.